Assalamualaikum warahmatullahi wabarakatuh. My name is Mohammad Sabri Zamli from Mechanical Engineering. Today, I would like to present my final year project which title is Oil Pump FFB Lifting Device. For this project, I am supervised by Dr. Hairul Anuar Abdullah.
Before I start, this presentation slide will consist of 5 chapters, which is Introduction, Literature Review, Methodology, Result in Discussion, and Conclusion and Recommendation.
Chapter 1, Introduction. This chapter will consist of problem statement, objective, and scope.
What is oil pump? According to Malaysia Palm Oil Council in 2019, Malaysia is one of the largest producers and exporter of palm oil in the world. Each tree produces compact bunches weighing between 10 and 25 kg with 100 to 300 fruitlet per bunches. Palm oil production in Malaysia has increased over the years from 4.1 million tonnes in 1985 up to 18.9 million tonnes in 2011. Why we need to design this lifting device? It is one way to overcome ergonomic related problem among oil palm plantation workers. The table below shows statistical data on body pain of oil palm workers in Malaysia. Next, the main objective of this research is to design and develop oil palm FFB lifting device, to do engineering analysis and FEA analysis on device structure, to design lifting device with load capacity more than 60 kg, and lastly, to implement the knowledge and skill in manufacturing process.
Chapter 2, Literature Review. This chapter will consist of product review, design review, pattern review, and transportation method of oil pump FFB.
First step, we will review the existing product. The product is the Krabby. It is used to exerting oil pump FFB in short pump area. It can withstand 1 ton load and it has 2.5 meter lifting height using hydraulic cylinder. Second is the Autoway. FFBs will be weighed automatically upon loading by workers. It will reduce workers' works used to weigh the bunch. The third product is Remount 328, developed by Samdabi Sdn Bhd. It is easy handling, user-friendly, low cost and versatile. It uses double-acting hydraulic cylinder to ensure smooth lifting. Then, we will review the existing design. The first design is linear actuated lift cart manufactured by Okudaya Giken in Osaka. The load capacity is 250 kg. The maximum height is 1.2 meter. The actuator used is hydraulic cylinder. The second design is high performance manual stacker. It is manufactured by Evertech Industry. The load capacity is up to 1 ton to 3 ton. The actuator is hydraulic cylinder with lever. The last design is hand winch lifter manufactured by Wesco Manufacturing. Wheels, the load capacity is 200 kg. The maximum output height is 1.778 mm and is using pulley system with handle to rotate the pulley. Transportation of oil palm fresh fruit bunches. The truck usually used to pick the oil palm FSP is 5-ton load capacity truck. The data below show the standard dimension of 5-ton truck that has been designed by Isuzu in 2019.
Chapter 3, Methodology.
We start our design process by preparing the design brief. Design brief is a descriptive document, describe the customer, clearly state the problem or need, the level of implementation of the solution by the engineers, and outline the rules and boundary for the engineer to carry out the solution. As you can see in the slide, this is the example of the design brief of this project. The second step in designing process is preparation of PDS. PDS is important as one way to determine the limit to our design. When we develop the DPS, it will be automatically done when our research background is success. In PDS, all the information of statement of needs and list of design specification will be included. The next methodology is function decomposition block. This function decomposition block is used to determine the flow of work of our lifting device. First, we have storage and compartment where we load the FFBs. Then we will lift the load by using the mechanism to lift the load. And lastly, the transportation method used by our lifting device. Next, in concept generation, we will use morphology chart. Morphology chart is used in order to generate idea based on function decomposition block that had been prepared earlier in our design process. This method is important in order to get the general idea for our conceptual design. Besides, the method of implementation of function in this block must be stated accordingly in the morphology chart. After we done the concept generation by using morphology chart, we can start do some conceptual design. In this case, I designed 4 different design based on the morphology chart that use 4 different mechanisms that show the difference of this conceptual design. Evaluation metric is used as the first step in design evaluation and selection. The design will be evaluated based on the criteria needed in order to develop the best lifting device such as functionality, rigidity, practicality, cost, etc. The criteria will be created. The higher the rating for the criteria makes the criteria more important as we continue to design. After the evaluation, the conceptual design 2 will be chosen as a datum in order to proceed to the next evaluation and selection method, which is pure metric. Before proceed to evaluation by pure metric, the student need to do some modification on the other design that not been chosen in evaluation metric. After doing some modification, the design then will be evaluated by comparing the positivity, negativity or the similarity of modified design with the datum design. If there is more possibility in modified design, then the new design will be chosen in our final concept. Thus, after doing some comparison, the design 1 is the best design to the final concept as it offers the best practicality and able to achieve our main objective of the study. After going through the concept evaluation, this is the final design for our oil pump FAB lifting device. The component of this device is oil pump FAB compartment, scissor lift, manual hydraulic pump mechanism and mainframe. The mainframe will be mounted to the side of the lorry by using bolt and nut. The oil pump FAB will be put on the oil pump FAB compartment and the scissor lift will lift the compartment in order to put the oil pump FAB onto the lorry. Next, we will use failure mode and effect analysis or FMEA on this device. FMEA is used to determine the possible failure and its effect on this device. Next, we will provide remedy action in order to tackle this problem. For example, for mainframe section, the failure mode is Wellman failure, and the effect to the device is the connection between two rectangular tubes will be break. So, in order to tackle this problem, we will do some FEA analysis before we design, and we will also use suitable electrode for the type of steel we use for the fabrication.
Chapter 4, Result and Discussion. This chapter will consist of visual prototyping and FEA analysis.
Visual prototyping will consist of embodiment of design and manual hydraulic pump mechanism. This is a CAD model of our full device which consists of FFB compartment, scissor lift, mainframe, and lastly manual hydraulic pump mechanism. This is the design of the FFB compartment. The component in this design is compartment, door, door lock, and bolt and nut. The door can be opened and closed automatically, and the design of the base is inclined, so the fruit can slide itself automatically onto the lorry. This is the design of scissor lift. This design consists of upper base, zigzag ram, hydraulic cylinder, lower base, roller pin, and pin. The hydraulic cylinder will be powered by manual hydraulic pump mechanism. Finally, this is the design of manual hydraulic pump mechanism. The component is pump mechanism, ball and nut, lever support, pump lever, upper case, oil refill cap, release valve, and lower case. The lower case is the oil storage. This figure shows the piping route in pump mechanism. Pump lever is used to pump the hydraulic and the oil will be moved to the hydraulic cylinder through the oil supply line. If the user want to refill the oil, they can do so by inserting the hydraulic oil through the oil refill cap. Release valve is used to return the scissor lift to its original position. By opening it, Air pressure will suck the hydraulic oil from cylinder back to the oil storage. Then we will proceed to simulation analysis. The analysis is done to determine the condition of the critical part after specific load is applied. Boundary condition is set in order to ease the analysis process. Different material is also applied on the part to be set as manipulating variable in this analysis. The first analysis is frame stress analysis on scissor lift. We put 981 Newton load on the upper base of scissor lift and we set the lower base of scissor lift as fixed geometry. The table shows the number of meshing on scissor lift and also we compare the two materials with each plain carbon steel and AISI 1020 steel. This table shows the properties between two materials. This is simulation result we get by the software we use to compare the two material in this analysis. This is the result table when we compare stress, strain and deformation of these two types of material. The deformation for AISI 1020 leaf is 1 mm, thus the design is still in safe limit based on its rigidity. Compared to plain carbon steel, the deformation is lower than AISI. If 1 meter stress is to be compared, the difference is very small and can be considered same. The stress is still less than allowable stress, which is 352 MPa. Based on their density, AISI is more rigid compared to plain carbon steel, but after simulation is analyzed, plain carbon steel has more strength compared to AISI 1020. The next analysis is welding strength analysis. In this analysis, we will compare when we use two different electrodes, which is E70 and E80 electrode. The table shows the properties of these two electrodes, which is the weld strength is for E70 electrode is 319 MPa and for E80 electrode is 364 MPa. In this analysis, we put 100 Newton load and the fixed geometry is as shown in this picture with the green color. This is simulation result we get by the software we use to compare the two material in this analysis. This is the result table where we compare the deformation, equivalent strain, and welding strength of these two types of electrode. The usage of different electrode type does not give any difference on deformation and strain value of the specimen. Despite in terms of welding strength, E80 electrode is more superior, the data collected shown that weld strength does not affect the deformation of the specimen when 100 Newton load is applied. In conclusion, during fabrication work, these two types of electrode can be used for welding process.
Chapter 5 Conclusions and Recommendation.
In conclusion, this research provided a vast knowledge on the transportation method of oil pump FFB of an oil pump plantation, where the condition in the existing plantation needed to be taken into consideration before any of the improvement or amendment done. The solution provided for the design lifting device is considered more ergonomic compared to using chisel that may cause the workers to face critical back problem in the future. By designing manual operated lifting device, the cost can be cut and small oil pump plantation with limited budget can afford to use this device commercially. FEA analysis is done on different material to check the suitability of the material to keep up with higher load, and as a result, by applying the load up to 981 Newton on the device, the stress, strain and deformation on the device is considered a designer and managed to choose the best material. By providing the data collected, the feedback from client can be achieved as client wanted to see how this device can be used as the best alternative to the old method used. In the future, we will provide detailed analysis on chemical properties of oil pump FAB that may affect the life cycle of lifting device. We will do future research on more high technology lifting device and adding features that suit the demand of Industrial Revolution 4.0, such as the implementation of IoT or adding sensor to the device. We will also provide the best documentation by considering to patent this device and do mass production, where the device can be commercialized in every oil pump plantation in Malaysia.
That's all for me. Thank you for listening.